are going, this test is conducted to predetermine the voltage regulation of the three-phase alternator by EMF method. This method is also known as synchronous impedance method. Let us start the experiment. For that, just click the experiment number 5 and drag it to the workspace. Now you can see the circuit of this experiment. Before this circuit, you can see the ratings like DC shunt motor ratings and then the alternator ratings. You can see the shunt motor speed is 1500 rpm to 2000 rpm, and then the alternator speed is 1500 rpm. It has a pole 4. By seeing this, you can see that it is a non-salient pole type of alternator, because non-salient pole type of alternator has high speed and then less number of poles. And let me explain the circuit. Here you can see the DC shunt motor. The shunt motor acts as a prime mover to the alternator. The output of the shunt motor is given as the input to the alternator, because the alternator and shunt motor are mechanically coupled. And then the alternator is excited using the DC source. Here we are using the switch is double pole single throw switch, and here you can see the rheostat. This rheostat acts as a potential divider. It is used to increase or decrease the voltage across the stator of the DC shunt motor. And we know that this alternator is a three-phase alternator. Here you can see the phases R, Y and then B. And these phases are open circuited. The voltage across these phases are measured using the voltmeter. And we know that the alternator field is excited externally using the DC source. Here you can see the circuit for this, for that external excited DC source is there, and the field current is adjusted using these rheostat. And you can see the tachometer here. The tachometer is used to measure the speed of the alternator. And before start the experiment, make sure that all the DPST switches are kept open and the rheostats are kept at the maximum position. Okay, now let's start the experiment by closing the DPST switch. Now we are going to vary the rheostat till we achieve the rated speed. We know that the rated speed is 1500 rpm, and you can see that as the voltage increases, the speed also increases, because speed and voltage are directly proportional to each other. Till we are getting the 1500 rpm, we are varying this. Here you can see some voltage across the open circuit. That is due to the residual magnetism. We got the rated speed. Yeah, we got the rated speed. Now we are going to excite the field, and we are going to vary this rheostat till we achieve the rated voltage. That is what we saw here. That is the force 15 volt. Till we reach the saturation, we are going to vary the field current of this alternator. Before getting that, we are going to store the values for the calculation purpose. By clicking the start storing data, we can store the values and then increase the rheostat, then start storing data, and now we are going to increase some amount, and then start doing that. Before reaching the 470 volt, try to get maximum of 10 readings. Start storing data. With this data, we are also going to plot a graph. Our rated voltage is 450. To that we are increasing. Now we got 413. Start store on data value. And then next thing, okay, we got the 417 volt. It's okay. Store the data and then show the data. Here you can see the stored data. We can also plot the graph by clicking this one and then click the generate graph. Here you can see the graph versus the current and the voltage. You can see as the current increases, the voltage also increases up to a certain level. After that, after the rated voltage, it will reach the saturation region. After that, how many times you can increase, it will remain constant at this rated voltage. These are all the things I would like to discuss in this experiment. And then before going to switch off the supply, reduce the DC shunt motor voltage and then switch off the supply. Thank you.